and gentlemen, please welcome Executive Vice President and CTO Red Hat, Brian Stevens.
Hey, good morning. So to me, and I know it's probably not the smartest thing that I could say to open up a big conference, but it's certainly honest. To me, the IT industry 6 to 7 years ago was getting a little bit boring and a little bit mundane. And it wasn't that open source wasn't impactful, it really was. Open source is absolutely getting adopted in all corners, but it was still viewed 6 to 7 years ago as a replacement strategy for existing IT functionality. And so you fast forward from just 6 to 7 years ago to today, and now open source and cloud technologies is absolutely igniting the whole next wave of innovation. And so it's happening everywhere, right? Developers globally are getting connected and getting involved. This isn't a one vendor thing from Hong Kong to Warsaw to Sacramento. Developers are getting involved. They start by getting inspired by others. In turn, they become proficient, and then in turn, they are actually inspiring new developers. And so in just short order, open source has actually become the biggest collection of intellectual property in the world, except it's not. It's actually shared openly. And the difference that's happening now is that companies that are traditionally not even in the software business are using software to innovate. And what they're doing, though, is they're taking a step further. They're not just using open source inside to innovate. They've decided that they, too, want to share that technology with others. And they're doing that because they understand it's not just about the code, it's about getting others involved. And if they can share their tools, their open source tools that they're using inside of their business, just allowing that influence of other customers and other developers make those tools all the better. So it's no longer in this era about one singular, large, massive transformation shift. One of the biggest things that we face today is not what's the next big thing we need to create. What it's about today is how do we actually take technology, community-developed technology typically, and get it across the gap and get it successfully into enterprise IT operations. And as part of that, it's not about a singular change. It's not about one thing. It's about countless numbers of small, incremental technology changes. And how do you bring those inside of the platform and get them inside of enterprise IT? So that's not to say, removing proprietary software and replacing it with open source that's faster, better, cheaper, and more open is a great thing, and it's been driving our business for the last 15 years. But the most interesting thing are these new cornerstone technologies that aren't just replacing software, they're having a fundamental impact on the operational IT environment for our customers. And that's really what gets us excited. That is the Red Hat mission, not just to be replacement software, but to drive change inside the operational landscape of IT. So that's what I want to talk to you about this morning, is just picking a couple of areas of technology that has the ability to transform and bring new capability that IT never had before. So I love the story of Docker. It's cool technology, but the reason why I like it is not just about the technology, but just sort of how the technology came to be. It's really not about the operating system. Even at Red Hat, biggest product line, we get that. It's about everything that the operating system enables. The fundamental thing is to make sure that everything developers need from application runtimes and application services are available, and that then those applications can run securely, reliably, and with great performance. That's our job. And it's not just making sure the app runs when you want it to. Increasingly, it's about making sure the application runs where you want it to. In the past, that has meant supporting thousands and thousands of different variations of physical hardware. And to be honest, that's the bane of our existence. We don't get a pass on that today. We still have to do all of that. But in addition to that, we have to support the hypervisor of choice that our customers need in their environment. And then we add to that supporting public clouds as well as private clouds. So some early innovation, that happened at Red Hat was making it easier to package applications and install the applications. In this case, an application could be, an email server, or it could be a whole new compiler tool chain. And so that project was called RPM. And what RPM did is it made it easier to actually build software from source. It made it easier to cryptographically verify that package, which meant you could trust who you got it from, and you knew that the software was not tampered with along the way. It made it easier to build these application repos for installability, and it made it easier to install the application on your platform, managing all the dependencies, and then to be able to uninstall it when you need it. So RPM was so useful that it was one of the biggest reasons why Red Hat Linux became the most popular software distribution, Linux distribution. And after that, RPM was actually ported to both NetWare and AIX. But that was 17 years ago. And since then, not a lot has happened in the space of application packaging. In fact, we continue to try to even jam things like Java inside of RPMs to try to drive that to better package installability. But that was then. And then today, along comes this company called Docker, right? And they were in the early PaaS business, a crowded marketplace of people building platform as a service. And while they weren't overly successful in the platform as a service business, along the way they invented some technology called Docker. And in the last year, the company has focused exclusively on the Docker technology. And then because of that Docker technology now in the past year has become one of the most popular projects on top of GitHub. And what Docker does is it makes it even easier in RPM to package up software, to share those applications, and to install it on a platform. So in this model, applications are essentially stacked layers of file images. And what that happens is that to share them, you can either use the Docker file as it is, or you can swap out a layer and customize it further, or add your own refining layer on top. And so as part of that, that's why Docker is so useful, and there's thousands and thousands of projects on GitHub for sharing these applications. So through that customization, what we're seeing is that on these collections, people are adding a layer on top, or they're swapping one out. But the thing about Docker is it's not just the application, how you build an application, it's actually the fact that it was designed for running inside of a container, right? So containers aren't a new thing. Containers are technology that has been being developed. There are some models in Solaris, but on the Linux side, container technology has been coming to be for the better part of the last decade. And what it does is it provides both full security for around an application, as well as the isolation around the application. And then in so doing, it provides a greater efficiency than just virtualization. So when you look at sort of a common x86 platform, it's very typical if you're going to virtualize, you're going to get about 10 virtual machines per physical system is on average. And containerization brings that to a whole new level of density, where it's not uncommon to get hundreds of Linux-based containers on a single physical system.
Docker is a fairly new project, right? It's exactly 1 year old, but it's actually the result of many years of work at .cloud. Our goal with Docker is to change the way software is created and distributed for this new kind of environment that we call the cloud.
We want to build weapons of mass innovation.
Actually, no, not weapons. Our mission is to create tools of mass innovation.
In our ultimate view of the world, developers are able to build the applications that they like flexibly, rapidly, unleashing all of their creativity without having to be constantly worried about how things are going to run.
We want to create the tools that allow a whole new generation of developers or future developers to do things that are completely impossible today.
Like all good open source projects, users are widespread and constantly surprise us with what they do with Docker.
Probably because it's such a simple, fundamental component. So it felt really like we handed over something like Lego. So it really felt like the community discovered this Lego brick, and the variety of things that it turns out you can build with Docker is mind-blowing even to us.
It was very gratifying to us that when Red Hat came to us, they didn't just come with a piece of paper.
We met with Brian, talked about the potential of working together. I think literally in a matter of weeks, there were engineers involved.
They came with developers and dove right in, which is the way that we work, and made huge contributions. And so as a result, we were able to make Docker work seamlessly with Red Hat Enterprise Linux, and we've got really exciting things in the works with OpenShift and OpenStack as well. The momentum that we're seeing around the project is really unbelievable. The community is growing is growing by leaps and bounds. There are over 7,500 applications that have been published. We have over 350 contributors to the Docker project. There are over 40,000 people who have gone through Docker training. Over 1.2 million Docker containers have been downloaded. And my own sort of personal favorite, there are now meetups in over 55 cities around the globe.
It takes a special kind of company to understand how to contribute to an open source project in a productive way. And Red Hat gets it, for sure.
So Red Hat's embracing it because it is innovative technology, and we're bringing it out in some of our core platforms so that customers can take advantage of this new flexibility. Some of the things we're doing is we're creating a lightweight version of RHEL, Container OS, because at the base layer of all these Docker files, these Docker images, is the user namespace and the user part of a Linux OS. And so what that Container OS delivers is all the things that in support of an application from libraries and runtime services that developers depend on. And then in addition to that, all of the control services that you want living inside of the container that admins need in order to manage containers at scale. And then underneath all of that, Red Hat Enterprise Linux is being taught to be a host of applications delivered as Docker containers. And that's what Project Atomic was about that we announced yesterday, was how do we focus on building a lightweight RHEL host that is optimized for managing and running containers at scale based on Docker. So it's been almost 10 minutes, so it's time to actually talk about cloud. We avoided it for a little while. Cloud, it sounds like it's something that's been here forever, but it's actually only been around for 8 years. At least that was the time when two gentlemen from South Africa working at Amazon that really conceptualized what would later become EC2. So in only 8 years, though, the industry has decided that we need to categorize clouds, that we know enough about them that we want to put them in categories. So we've created infrastructure clouds, platform clouds, software as a service clouds, but we were largely wrong, right? These categories are already starting to converge. You look at Amazon itself, right, or even look at some of the announcements that Google had a couple of weeks ago, and if you walk through service by service by service, looking at AWS, you'd be really hard-pressed to decide which of those services was an infrastructure service and which was a platform service. And even if you could make that delineation, I'd argue that it doesn't really matter. So 3 to 4 years into our collective engineering development around OpenShift and OpenStack, we're seeing the same sort of convergence that's happening. Both products and capabilities bring great operational efficiency to our customers even when used separately. But what we're finding is that as we better integrate them and use them together, that they end up with more capability and a better end user experience for both the end user as well as the IT operations. So I want to give you a few examples on that to make that tangible. You look at Heat. So Heat is a orchestration language that is actually a formal part of OpenStack. And what's happened is all the platforms as service efforts, OpenShift, Cloud Foundry, and others, have invented their own way of doing service-level orchestration for apps, which is kind of ridiculous because having the exact same model for service orchestration and templatized apps has a lot of end-user benefits. So that's why at Red Hat we're sort of converging, towards Heat, even for OpenShift. On the OpenStack side, OpenStack, for some reason, we've said that OpenStack, the resource it creates is virtual machines, right? And then you look at PaaS. You've heard a lot about Docker and containers this week, but you look at every platform as a service, and they're not just speaking virtual machines. They want to actually think about containers. So what we need to do is we need to teach OpenStack itself about containers as a first-class resource. On the load balancer side, OpenStack has ideas for load balancers, and the reason why they deploy and manage load balancers is because they want to help IT with the scale and resiliency of their environment. But then all of a sudden, the ability, that only goes so far when you start thinking about PaaS. At the PaaS level, you're starting to think about how do I make the whole application elastic? How do I scale out my database, my app server? And so those two really have to come together and really get unified. And the last example I want to give you is around monitoring. So OpenStack has a core project called Salometer around monitoring. And that monitoring stuff is just used for the OpenStack services, which is fantastic. But what that means is then the PaaSes that are out there are all inventing their own ways to how you actually monitor applications and application health and application response time. And what you really want from my IT perspective is not to be beholden to the two artificial lines. but a single mechanism for doing application monitoring all the way down through hardware. So because of that, the OpenShift team and the Red Hat team specifically has gotten a lot more involved in OpenStack. And so what they're doing there is they're actually joining projects and creating projects to drive a deeper level of integration.
Companies are facing a problem, which is that developers need to be able to rapidly build applications and deploy them. And on the other side, administrators need to be able to put the resources in place that allow them to integrate. But at the same time, those two extremes don't quite have all the information. They don't see the picture together. If you have a product on top of OpenStack that is disjoint, that isn't deeply embedded with the OpenStack process and the OpenStack capabilities, you have that same sort of organizational boundary where the people who are dealing with the platform as a service don't really understand what's going on in the infrastructure as a service, and the people dealing with the infrastructure as a service don't really understand what's going on in the platform as a service. So it's all about bringing those two closer together, finding the right mix of capabilities that says, I'm an application developer and I want to build applications. I want to do that on top of OpenStack and make that natural from day one. The core of Project Solem is to take developer source code, to generate images. An image can be deployed on a VM or a container or a Docker container or on some system that hasn't been invented yet. And by using Heat, we can take all of those images, deploy them in a consistent way into production, and give administrators the flexibility to tune how those applications look over time. So the responsibility of Project Solem is that flow and allowing organizations to fit their pieces and their processes into each spot. And the additional capabilities that we want within OpenShift are that tighter integration with the infrastructure to allow people within the organization to manage all of the resources that are used by OpenShift. So not to have two different frameworks or two different systems for managing and controlling what's going on in an IT organization, but to kind of have a consistent view from the bottom up. And the top level is always those applications and the people who use them. It's never about just the infrastructure or just the applications. It's that unified view of both of them. And so the people who run applications and the people who write applications aren't always the same people. But if they're not working together, an IT organization can't succeed.
So when I talk to customers, they're really not looking for an infrastructure cloud and a platform cloud. From us, they're really looking for a unified cloud experience. So I want to talk to you a little bit about programmable IT, but probably a better title for this chapter is really like, how do you help IT operations scale? So in the world of DevOps, we talk about small teams of sysadmins that are managing hundreds of applications or thousands of applications across tens of thousands of servers. In the IT world, it's not unusual for there to quickly be thousands of things that IT needs to manage, from computers and servers and applications and storage and networks. And the traditional operational model means that as the business is successful, as the operational IT environment grows and the number of managed things grows, so too must your IT team grow. It's really been a linear relationship, and therein lies the problem. In the DevOps era, the whole goal is to break this linearity. But they're not doing it using our father's graphical console because it doesn't scale. They're using software. They're taking software and they're programming it by writing their own applications to orchestrate and automate their entire IT environment. And so doing what they've done is they've essentially taken the deployment of IT architecture and turned that into running code. The problem is you can't wrap a DevOps model across an IT platform that's atrophied. The underlying IT platform has to support that programmability. So what that means is the existing IT functions have to be modular services that each presents an API so that it can be orchestrated. So with virtualization, we're kind of already there, right? We get it. We know that we no longer need to physically deploy hardware just to deploy an application. You can write a shell script today that just creates a virtual machine. And then you can add on tools like Puppet and Chef, and you can go a step further and you can deploy, configure, provision the OS and the applications. On the storage side, it's not as far along, right? Applications have a lot of requirements for different types of storage, ephemeral storage, persistent storage. And so that's creating a whole new wave of software-based storage. Red Hat storage, Gluster for Red Hat was designed with an API in mind so that IT and applications could actually scale out the provisioning of storage and the manageability of storage, whether that's, whether that's block, whether it's file, whether it's object, it doesn't really matter, and then using the language of choice for IT. The network has always been the bottleneck. It continues to be the bottleneck. When you think about it, you want to flexibly deploy tiers of applications and their data services, and you want to virtually connect those together on the network, independent of the underlying physical network. And it's just hard to do that today, but there's 3 open source projects that are really sort of leading the whole industry around breaking that down: OVS, OpenDaylight, and Neutron. OVS is the piece of technology that creates the notion of an open virtual switch that actually runs in the endpoint. So that runs inside of Linux, runs inside of KVM, and that way at the endpoint understands virtual network switching topology. Neutron is a formal part of the OpenStack project, and what that's doing is it's creating that API to all things network, or SDN. So it presents out the API that IT and applications would need to orchestrate the network, and in many cases it can talk to physical hardware by plugging in the physical hardware, or it in turn talks to OVS. And then as your network scales, as it gets much larger, that's when you introduce the notion of a software-based, typically distributed network controller. And our effort around that has been joining a community effort of OpenDaylight. It's creating an open source SDN controller, and those controllers plug underneath Neutron, and that gives you the greater scale.
This is a project that started off with a lot of naysayers, not really sure where this project would go and how it would be successful. A year into it, we have a lot of people who have changed their minds, and they're really supportive of the work we're doing and seeing that this is a group of engineers who are passionate and focused on building next generation open source SDN controller. A core new focus in the OpenDaylight project is connecting OpenDaylight to OpenStack. As a community, we've built a plugin for the OpenStack Neutron service to communicate from the OpenStack networking services to OpenDaylight. And OpenDaylight itself has a notion of pluggability. So there are a number of different ways you could manage your fabric, your physical infrastructure. And this is another place where we can work with our partners to certify their solutions around their fabric management. An exciting new development in the networking space is network functions virtualization. NFV is a new concept. It's a concept that was generated by operators, service providers in the telecommunications industry, looking to build infrastructure based on clouds using SDN technology to move network traffic through each of these virtualized functions to provide new services to their end users. This is an exciting time for Red Hat. The combination of OpenStack and OpenDaylight, open source technologies to build cloud infrastructure and manage the networks within a cloud, combined with an ecosystem of network functions relevant to the telecommunications industry, is giving this industry the ability to redefine its future. One of the most important components of an open source development effort is the community. And this is the excitement that I see in OpenDaylight. We've gone from a nascent project to a project that's delivered an open source SDN solution just recently in early February. This was a huge milestone for the project. This shows a community coming together, collaborating across the industry to build an open source SDN controller. And the energy, the enthusiasm, the inertia generated by this first release is something that we're really excited about.
So I think we know we live in a world where software is innovating faster than hardware, and we've quickly understood that it's easier to deliver IT functions as software and applications than it is to deploy hardware. And that same movement's actually happening inside of the telco and service provider marketplace. That's what's created the movement behind NFV, or network functions virtualization, is in the telco space, all of their existing networking functions and services, from payment to billing and gateways and mobile support and messaging and VoIP, have typically been delivered as purpose-built engineered systems that include software and hardware. And what's happening with the NFV movement is that whole industry, led by the end users, led by the telcos themselves, is taking the software inside of those hardware silos and pulling it out and delivering it as virtualized applications across their enterprise. And it marries really well with everything that's going on with OpenStack and SDN, because the SDN layer is what allows you to sort of orchestrate those network services and chain them together. So in time, I think we'll see, that programming the existing, virtual networking environment as well as the network services is really going to be as simple and understandable as today it is to just launch a virtual machine. So switching gears on continuous integration and continuous deployment, this is really a case of sort of technology that's enabling the way for massive process innovation. Talking about waterfall engineering, it's a really beautiful name, but it's really wrought with challenges. It's an idea that dates back to the 1950s, which tried to put a model around engineering in general, where each phase is from requirements all the way through validation was really finite. You could validate each stage before you moved on to the next stage. And that was done because of the rigor of engineering. It was so expensive to make a mistake and going back. So it was a really fixed process. But now when we talk about waterfall engineering, it's often very critically when we speak of it. And then you contrast that with today. Now we live in a world of user experience and design, prototypes, collaboration, and scrums. In today's world, the only thing that you can count on is that the requirements on developers will change over the course of that whole development cycle. And in this world, the waterfall model just makes that far too expensive. Then you add on top of that, the land of open source, where the people working on the same project as you are probably working, on behalf of different entities if that project is successful. So it means you may even have conflicting requirements of engineers working on the same project, and that's okay, because in the open source world, it's not a requirement to drive alignment of how you think just to participate. And then now we magnify that one step further, and we take what were simple projects to these massive scale projects like Linux and OpenStack. The legacy model of software engineering just isn't going to survive this transition. So as we move forward in our labs, we've even started to use CI/CD in our development process. And the goal is actually just to have a running system each and every day that mirrors your development tree. And in so doing, you're actually taking the changes as they are made, you're integrating them through a CI system into your running system. You can see how those changes interplay with other changes. You can get a feel for how the system looks as a whole. And if you can do that, that allows you very early in the development cycle to get a feel of what the whole entity looks like and have that feedback loop to change course if needed. So Red Hat Linux is clearly the largest organism inside of Red Hat. It's this massive scale integration project. We're integrating community developed technologies to integrate with other Red Hat products, working with our partners, often technology that's even under NDA on behalf of our partners. And it's this sheer complexity of the size of the project that means it's perhaps one of the best benefactors of a process like continuous integration, continuous deployment. So when the upcoming RHEL 7 release comes out, that'll actually be the first enterprise Linux release where we've started to deploy the value of things like CI. On the OpenStack community side, there's a community effort to build a CI/CD system in the public domain.
It goes back to the first principle of the Agile Manifesto is that our highest priority is to satisfy the customer through continuous delivery of valuable software. From a customer perspective, I think the kind of utopian ideal here would be that in your production environment you're seeing a constant flow of new features, of new value. You have the ability to give very rapid feedback, relevant feedback back to the developer about how useful the new feature was. The feedback loop term kind of brings us back to DevOps and the notion that traditionally in IT there'd be this enormous gulf between your developer team and your operations team. We really hope that OOO is going to become the underpinnings of the next generation of OpenStack's CI infrastructure, so that developers, when they're working on code, when they're testing their code, are testing it against a more realistic kind of production-like deployment of OpenStack. There's this gap between developers' understanding of what features are required in the project versus kind of what operators think are important in terms of their needs for actually operating and managing the project. And Red Hat, I think has always provided a lot of value around bridging that gap. But we're trying to, I guess, shrink that gap a little bit more and enable, shorter release cycles and a really closer feedback loop between the customer who's operating the software and the upstream, the developers who are developing the software. Because of the amount of development going on at OpenStack, I mean, we're launching thousands of test jobs a day, and it's really a phenomenal system to just see it running, to look at the dashboard of this continuous integration system and the number of jobs running and what that represents in terms of the amount of development going on, the velocity, the confidence that we gain from that system. And it's only going to grow from there.
You know, on this front, sort of success can become a problem, right? Because just the sheer size of the new developers joining OpenStack, the pace of the development, the size of the development team, has meant that it's been really difficult on a regular basis to get a view of sort of what's the current development tree of OpenStack even look like. And often we have to wait too far at the end of these 6-month cycles, these mini waterfalls, if you will, to get a feel. And that's really what the goal of OOO is. The OOO is like, how can we get a running CI/CD system that allows us to take the latest tree, integrate it, and deploy it so that developers can have a feel for, are we heading in the right direction? And that gives you a daily view of the current OpenStack tree instead of waiting at the end of 6 months. So if successful in the future, this whole thing as a service could actually be used as a gate, because if it's successful to really understand the impact of change, we also can reject change before they're submitted to the OpenStack tree if they have negative consequences overall. So when we talk about big data, we often talk about volume and velocity of data, and how the amount of data in the world is doubling nearly every couple of years. Well, what's interesting, increasingly we're talking now is about volume of data. We're not just talking about data as a cost. The businesses are starting to think about data actually as an asset. Storage used to be expensive. And what that meant was you had to make decisions. You had to decide what data you were going to retain and what data you had to discard. So invariably, those decisions could be wrong. So it meant with that discarded data, so too you lost business intelligence that could have moved your company forward. And even when you can home the data, even when you can save and store all the data, what we've observed is that often that data is compartmentalized in silos across the business. And so that leads to this thing called the enterprise amnesia, a phenomena where businesses even often have all the data that they need, but they're not able to integrate it, correlate it, and make decisions across it. The knowledge is kept in silos. And that's the problem that Red Hat Storage, based on open source cluster, is actually trying to solve, is how can we store, scale, and secure petabytes of data? And in addition to that, how can we make those petabytes of data support in-place data analytics to support business intelligence? Red Hat Storage, it's cost-effective and resilient because of its architecture. It stripes, replicates, shards data across clusters of commodity hardware, right? In the exact same fashion that you can imagine how every data service in the public domain for public clouds do. Yet, it still easily integrates into an IT environment because we've ensured that it conforms to industry standards around file access and object access. That's the storage side. When it comes to big data, you're not just thinking about storing the big data, you want to analyze it. And that whole movement is led by open source and typically Hadoop. What we've done is to bridge cluster storage into that world and Red Hat Storage into that world. We've created the notion of not all Hadoop has to run on a purpose-built file system just for Hadoop. We've actually taught Red Hat Storage how to speak the language of a Hadoop-compatible file system. And so what the benefit of that means, not only can you scale and store your data in cluster in Red Hat Storage, but you also can take tools like out of the Hadoop community like MapReduce and run them directly in place on your storage. And this whole world's moving forward really quickly. Just sort of the move towards large memory sizes and persistent memory has meant that all of a sudden there's these new opportunities for architecture for data analysis that has created new projects like Spark and BDAS, and how those can actually deliver more real-time analytics than even the existing legacy Hadoop stuff. So, Red Hat's already looking for what are the paths of integration where we can help our customers take the next generation of analytics and bridge them into the storage platform.
because of the explosion of data, it's been very expensive to keep all this data around. And so what we've seen is people choosing to discard data after particular time periods. And so one of our key products in this area is Red Hat Storage. And Red Hat Storage allows people to really inexpensively store and manage their data. But that is only half the problem. In order to have business insight on your data, you've got to be able to run analytics on it. So what we've done is we've brought the entire Hadoop ecosystem to Red Hat Storage so that you can run Hadoop analytics. So you don't run into issues of, one, I can't keep my data around, and two, even if I do, I don't have the processing capability to be able to analyze it. And all of this allows you to be able to derive new insights with your data. Red Hat has contributors and committers across a number of different projects in this space. We're tracking it very actively. One of the things that we're doing in those communities is bringing interoperability and reliability and choice. You know, our customers are telling us this is really important to them. So one of the projects that we're really proud of is Project Sahara. This is a project that we're working within the OpenStack Foundation. It used to be called Project Savannah, but essentially what the technology is it allows you to elastically deploy Hadoop on top of OpenStack. Typically, these would be dev or test clusters. It just simplifies that. It allows you to leverage your existing OpenStack investment and deploy it for use with big data. In that same vein, we're exploring nascent projects in the big data space and looking to bring those same values to those projects. We're looking to work on machine learning, deep analytics, the Berkeley Data Analytics Platform, and Spark, which are these open source in-memory architectures that bring huge performance gains. So Red Hat's actively involved in all these communities, and we're continuing to bring the values of openness, reliability, interoperability to keep choice available to our customers.
So as you can see, innovation is no longer one big, massive invention. It's actually a series of smaller micro innovations. And for a company like Red Hat, where our development team is the entire world, innovations actually become the easiest part of the business. And it's happening everywhere. It's typically unplanned, but it's always connected and it's always collaborative. And right now, it's happening here at the Red Hat Summit in San Francisco with all of you. So thank you.